Hello everyone and welcome to another episode of the code review. Today we're reviewing someone's Advent of Code Day 1 solutions that they posted on Reddit. This is from user KND256 who posted it on the code review subreddit like 3 months ago, but yeah, content. So I'm going to use it. And what we have here is the day 1, as I said, problem. The day 1 problem is this. You basically, you can pause and read it, but basically you want to take this sort of code right here, and we're basically taking the first digit and the last digit and combining them together. So like 3, 8 makes 3, 8, 1, 5 makes 15, and if there's only one, we take it twice, basically. And then we add them all together and we get 142, and that's our solution. So very simple. And then if we look at the input itself, it's a bunch of these, like in the example. And we see some things like 5 and 2 in here, but they're red herrings. They have nothing to do with the problem. And so this would, for example, be 8, 1. This would be 8, 9. This would be 7, 6. Yeah, pretty simple. I think we all get it. Now let's look at the solution this guy put out. Actually, let's first run it. And it went to the file. Okay, so it puts out 2 results. And if you don't know Advent of Code, it takes 1 result. So I can tell you from having solved this myself, this is right, this is not. Okay, we'll have to see in the code why that is. So let's go into main.c and see what's going on. I formatted the code with an auto formatter, but that's all I did. Yeah. So I've looked at this code very briefly to get an idea of the structure of it, because it's a lot of and huh and where is this function? You know, we don't need to hear that. So I've skipped that part for you guys, but I've looked at the structure of the code to sort of know what is where. It took me about 5 minutes because it's a bit more complicated code than I would have thought, but it is what it is. A few general sort of observations before we get into the code itself. There's a lot of this, and if you're a beginner in C, you might be like, whoa, what the fuck is going on? And it also took me by surprise a little bit because it's a day 1 Advent of Code challenge. But basically, this is a function pointer, right? And in this case, it's a function pointer to a function that takes a function pointer again in its arguments. There's another one here somewhere, the validator. Yeah. So this is from a functional programming background, usually. What I mean by that is people who write functional programs like in Haskell or Elixir or Erlang, whatever you have, they're used to passing functions to each other, higher order function type things. There's a lot of patterns and like programming patterns that use that. So I'm just gonna assume that the person who wrote this is a functional programming person, because otherwise I have to assume that they think this is super smart for other reasons, and I can't see other reasons. So this is generally a good idea if you have functions that are very general purpose algorithms, like for example a map function or a fold function. If you're into function programming, as I said, you will know what those are. Or even like an aggregator of some kind. But in this case, we don't have that. We have a very simple problem. So I would call this solution a little bit overcomplicated, because there's not really going to be a case in which you want to determine the first number like here, but then pass in a validator that doesn't validate whether it's a number. It's just, these arguments are very specific. I mean, there's a lot of, and these are not even type def. So if you were going to do that, you would type def these to give them a name. Yeah, a little bit overcomplicated for my taste, but we'll get into that a little bit more as we look at the code. So let's start at the main function, and we see that solve problem is called twice. And that makes sense because we did see it output 2 results. And it looks like what it does here is it passes a bool here to this to these functions, well, not to these functions, to this function here, solve problem. And then we can guess that it probably gives them to these functions later on because it's called the same thing. Strings on is not a bad name for a bool. I would be happier if this was a bool from standard bool .h, but it's okay. It's common practice to use an int instead, and the difference is really just syntactic sugar more than, I mean, semantically it's the same exact thing, so it doesn't matter that much. And just, if it, what does it mean if I put a 2 here? For an integer, that's valid. For a bool, not so much. So use a bool where you can. If it is a bool, make a bool. There's no reason not to. Let's go to the actual implementation of the functions right there. So we make a required information struct. Okay. So it's just not a good name. Required information is too general, so this should be maybe, I don't know what it would be. Maybe calibrations, data, I don't know, like, I mean, data is also terrible, but at least it's shorter. I mean, yeah, I'm just saying, required information. If this was a code review, which I'm assuming this is because that's the whole point of these videos, I would say, yeah, please rename this, and that would be it for the code review for that part of the code. It would just be, yeah, please rename this thing because, and for reference, I'm a professional software engineer. I do a lot of code reviews at my job. I do code reviews in open source projects that I maintain and stuff like that. So I do actually review code for a living. I also write code for a living, but we then call setup calibrations amended and give it the required information struct. What? Oh no. Oh, this is a pointer. Okay, so this is a pointer type def. So let's rename this so that I know it's a pointer type def because, yeah, that smells. As in the codes, like this is the code smell. This is not something you should do. You shouldn't type def the fact that it's a pointer, because it's gonna make it very confusing. Like if this is just like it was right now, required information looks like a struct. You pass it in, that's a copy. That's value semantics. You don't want that, right? You want reference semantics, which you get with pointers. So no real reason not to actually just have this be a required information pointer. And because I don't want to change the code too much so that it remains a more or less true to life code review, I'm just going to rename it really quick so that we don't stumble upon that anymore. Now we're going to go to this function. Okay, so we get a buffer, we have open, and then we read. Okay, there's a problem with this. There's a problem with this that is specifically, we make this, we run it with a file that doesn't exist, it will die. We run it with a file that we can't access, like root /rc, it's gonna die, which is not great. So what we want here is we want to check whether input file is null, because according to the documentation, that actually does something here, that checks it, for errors or some stuff like that. So you basically want a p_error open, which, you could put anything here like input file, but this is enough for us to know what failed, and then we exit with 1 or exit failure or whatever you like. And then if we run this again, then this is permission denied. The file that doesn't exist, there's no such file directory, and the input still works. So really no reason not to do that. Please do that. Then we get into the fgets loop here. Fgets should be fread, to be honest, but just because I feel like it, there's no real other reason, I think. Let's see. Is there a reason to use it? Yeah, I mean, it's a string reading thing, right? Which in this case is probably appropriate. Well, I don't know. I mean, we're only reading, so we're reading max calibration size, which is 1 kilobyte. and then we're not terminating it with fgets. Like, it just doesn't make sense. Just do fread because we're reading raw data, in my opinion. But oh no, we do string length. Okay, well, reasonably you would call fread and then use the return value of that to know how much you've read, and you don't need string length. I'll let it slide. And this looks like it's not right. Okay, so we start with calibrations amended being null. So this check will succeed the null check. So it is null, in which case we calloc, and in any other case, because it's a while loop, we will realloc. And we will add one char pointer, which makes sense because it's a two-dimensional array right here, two-dimensional array. So, yeah, this doesn't make much sense to do, to be honest, because realloc, as you can see here, I have the tab open already because I saw that realloc was used. Realloc allows you to just pass null and it will behave like malloc. So there's, other than this zeroing out, which is nice but not needed in this case, you really can just, you can just skip all this null checking stuff and, sorry, I'm jumping so much around, and just do that. This does the same thing. It mallocs when this is null, and like, let me actually show you. It still outputs the right thing. So no real point. Yeah, no point. Then we make a buffer for the actual. So temp buff lang is how many characters. Okay, so we read line by line and store them in a two-dimensional array. Fair enough. We don't need to get over this. It's like very simple. We null terminate. Very beautiful. I like that. We don't technically need to. No, we do, because we are copying only string copy. I think string copy does null terminate it. I think we end up with 2 null bytes at the end, but it doesn't matter. It works, so don't touch it. So after we do setup calibrations amended, we then go and this is a typo. Fix the typo. So correct calibrations are calibrations because the problem itself is an advent of code problem, right? So they have a quirky name for it called calibrations, but it doesn't really matter. So the calibrations here is actually a good name, whereas the required information is a bad name, as I said. Okay, so we then allocate enough to hold. Okay, so we make a second array, second two-dimensional array that has all the calibrations in it that are correct. So they basically, well, correct as in, I think these are just the solutions, right? Yeah, these are just the characters in the solution. I don't know why it's char pointer. Oh, because it's 2. Okay, fair enough. Because we call A to I here. Okay, yeah, fair enough. Then, so we store 2 of them. 0 is the first number, 1 is the last number, and then 2 is a null termination byte. So we can use ATOI on it, which is, ATOI is kind of ass, but for this case, it's fine. So I wouldn't actually comment on this one, that's fine. So here we see, again, we get these first number and last number things. Function pointers, we use them here, we pass them along. Actually, we call them and we pass isValid number, which we didn't pass in here, so it's not like, if anything, then this isValid number should have also been passed in here if it was to be more general purpose. But anyway, so let's go to the first number function, which is determine first number. And what this does is it takes these, it iterates through the string length. String n length is kind of nice, I guess, bounding it to the maximum size that this buffer could possibly hold. But then again, we did allocate this to be a fixed size before, so maybe storing the size of each string with the string is a little bit cleaner, but I mean, it doesn't matter. It's just the day one problem. I'm just saying it's not the cleanest solution. the author on Reddit where I found this was bragging a little bit, being like, oh, I think this is quite a clean solution. And if you're going to say it's quite a clean solution, you better not have string end length in a tight loop. So yeah, just store the size when you make it, when you allocate it, store the size with it, and then use it. But other than that, this is fine. If strings on, we run validator, and validator is, what was validator? Is valid number. Okay, so I'm gonna rename this. Is valid number function, because it's really what it is. It's not ever being called a different way, so let's just call it that, please. If it is a valid number, return the result of it. So this should really be, like, we should really just be saying this and then this. But there's actually a bigger optimization, as I see here. I'll call it an optimization. But if we look at the isValidNumber function, what it does is it pretty much just checks if it's a digit. And there is a isDigit from ctype.h, and we can just use that, and that does the same thing. Okay. And then we also have the strings on thing, and we need to talk about that. Okay, I'm sorry, we need to talk about that, because that is exactly the red herring I was talking about. And that's the one where the author thought that maybe it was relevant that these contain wordified numbers like 0 and 3 and stuff like that. And they do contain this, the input set contains this, but it's a red herring, and the task doesn't say this. And this is such an important skill to have, is to read the instructions and follow the instructions, because this is just trying to be a little bit too smart, just like with the rest of this program, just trying to be a little bit too smart and coming up with way too much code as a result of it. And the problem with too much code is that it's more code for everybody to understand, it's more code to monitor, to look for problems in, and it's more code that can have bugs in it. The less code you have, the better. And there's a certain beauty to simple solutions, right? And the reason for that is because simple solutions are very difficult to do. Like solving this in a simple way in C is a genuinely difficult task. And so I can't fault the author for overcomplicating it, because that is technically easier than writing it in a simple way, however paradox that might sound, but it is like that. So yeah, but this is not something that you actually need to do, and this is this solution right here, which is actually the wrong solution anyways. So what we're going to do, okay, is we're going to get rid of it. And this is turning into a bit of a refactor, but I'm just going to like not call this function, and instead I'm only going to call the validator like that. This is determine last number, and this is determine first number, same thing. Let's just pretend like strings on doesn't exist, and let's just handle the case that we know is right, because we read the problem description, okay? And same here, we can remove this as well, because that also doesn't do anything useful for us. So, and we run it, and it now, we call it twice, and it results in the correct result both times, which I would say is an improvement. But yeah, now as we look at this code, we realize that we don't actually care if it is a valid number. We just care to make the first a valid number into a digit, basically, right? So there's no point in checking. So really, we want this, right? Because if we check for it first, we just catch the 0 case, and 0, and it doesn't matter, at least in the first number case. In the last number case, it technically does matter, I guess. But the input set if it has a 0 in it, we actually want to catch it. And if it doesn't have a 0 in it, I don't know, let's see. So if it's digit and then return 0. So if we return 0, then we should be fine either way. But it just exits with 1 if it's not. So I'm gonna take a leap of faith here, and just return this digit. Can we do that? Oh no, we need to. Yeah, yeah, this is better. Let's check is digit, and then return C. And C, of course, is string string I. And I would argue that this is a little bit easier to understand and follow in terms of code than having a validator function that you pass in that then does if else stuff. Like, it's cool, and if the task did ask for that, that would be the only solution. But in this case, it's not the solution, so we're just gonna get rid of it. So this can go away, this can go away, and effectively, it's now a pretty simple solution. So the solution is to determine the first number, we walk from the beginning to the end to find the first digit, and to determine the last number, we walk from the end to the beginning. It's fine. I think that works perfectly fine in this case, and we're fine with that. That's fine. That's epic. Okay. I do think that there is a bug in setup calibrations appended, specifically the fact that we only ever read max calibration size number. In case this ends up being in the middle of a string, we cut the string in half. And so if we basically have a string over the 1 kilobyte boundary that happens to have relevant digits in it, or cuts it in half such that the relevant digits end up on 2 different sides of the buffer, we probably have a bug there, but I'm not gonna say we do because I haven't thought about it that much. I'm just noticing that as I go along. This is an error that everybody makes when they do like sort of chunked reading, is what do you do at the chunk borders, and you basically have to build a state machine to fix that, and I'm not doing that, and I'm not recommending this person does either because it works. Okay. But yeah, that's pretty much all the code. We then free the required information, which is why we don't have a memory leak, which is great. And I think the person did great, honestly. But really tone down the use of these, and just don't have them. And I mean, you don't need any of these things. And then suddenly this becomes very, very simple, easy to understand code. And that's beautiful in a way, right? Like, that's what you want. You want to have your code be, small, concise, simple, basically, right? Because then it suddenly turns into this, and then this turns into this. Oops, sorry. And we don't need this. And you see how the algorithm becomes more clear, even though it becomes less generic. It's like, determine, it's like this suddenly is so easy to read in comparison to passing around function pointers and stuff like that. It's just something that I would say is preferable in pretty much every single case. And yeah, let's just do it like that, and let's not goof around with trying to make it too general, over engineer it, if you will. And now we've cut it down from 170 to 114 lines, which is more reasonable, I think, considering we have a whole data structure for it, which we arguably don't necessarily need for this, but it's nice like this. It makes it easy to sort of follow where the code is. Where is it? There it is. And yeah, we just get the result, and that's it. And let's check for memory leaks really quick. But yeah, absolutely no memory leaks still, and I think this code is much simpler. So yeah, good job to who did that if you see my video. Hi. Awkward. And yeah, if you have code that you want me to review, please feel free to comment down below, give me a GitHub link, or send me via email. I don't think my email is listed anywhere, but if you find it, go ahead and have a good day.